final with a chance of winning the event again.
Gravitational potential energy is the amount of energy an object possesses depending on the position in the gravitational field. In the sport of diving, it is best represented while the diver is still standing on the diving board. In our scenario, we use David Boudier, who has a mass of 73 kilograms and is standing on top of a 10-meter platform regulated by the International Olympic Committee. Once you input the data into the formula, potential energy equals mass times gravity times height, you'll find that David Boudier has a potential energy of 7,154 joules.
As the diver jumps off the springboard, air resistance becomes present. Because of this, the energy is spent overcoming the resistance and it gets converted into thermal energy. Once the diver hits the water in the pool, all the potential energy has then converted into kinetic energy. But as soon as the splash is created, a sound energy is formed. Now we're going to calculate the time and kinetic energy of David Boudier. To calculate the time, the height is 10 meters and the initial velocity is 0 meters per second. Using this formula, the time given would be 1.42 seconds. To calculate kinetic energy, the mass is 73 kilograms, time is 1.42 seconds, and the height is 10 meters. Using this formula, the kinetic energy would be 1,800 joules.
In the sport of diving, waves can be seen in two scenarios, water waves and sound waves. The circles around the point of impact are the transverse waves created by David Boudier. This is due to a disturbance in the medium, which in this case is water. Also, when the diver comes into contact with water, two sound waves are created, one that travels in the water while the other one travels in the air. The speed of sound in an average pool, which has a temperature of 28 to 30 degrees Celsius, is a blazing 1,507 meters per second. This means it would take 0.03 seconds for the sound to travel from one side to the other in an Olympic-sized pool. The temperature in the building that contains the swimming pool is approximately 23 degrees Celsius. Once you input that temperature into the formula, you'll find that the audience hears the impact of the diver with the water at a speed of 345 meters per second.
Okay.
Brief from a springboard 2 meters high, from ground level or from the Olympics height of 10 meters, the initial leap is the key to the best dive. Our diver is evaluated based on the jump from the board, the rotation in the air, and hitting the water at 90 degrees. And this all depends on the angular momentum and the moment of inertia, which is what we're going to talk about in this video. If we use this for a falling diver, there's a force in y direction as the momentum increases as the diver falls. Furthermore, angular momentum is a momentum dealing with the rotational motion, and it depends on two things, the velocity and the moment of inertia. So the moment of inertia is a property of an object that makes it harder to change the angular velocity, and it depends on the mass, as we learned in the kinematics unit, and it also depends on the location of the object relative to the point of rotation. So further the object is from the rotational point, the greater the amount of inertia. Now that we know about these definitions, let's talk about the rotating diver. So the diver must jump very hard on the springboard so that it reacts and exerts equal and opposite reaction force, which will help change the momentum of the diver from 0 to greater than 0, which gives the diver the rotational motion. Final dimension of the diver before they hit the water at 90 degrees depends on the initial rotation, and in order to increase the speed, they draw the position into a compact ball so that they can overcome the moment of inertia, which also helps them conserve their momentum, which will help them have at least 4 rotations in the air. But even after they hit the water, the diver still rotates, so now they have to increase their moment of inertia in order to decrease their angular speed. The moment of inertia using the mass 73 kilograms and the radius of 3.35 meters using the given formula, the moment of inertia of the diver is 820 kilogram meter square. To find the angular velocity using the velocity of 7.042 meters per second and using the radius of 3.35 meters using this given formula, the angular velocity of the diver is 2.10 radians per second. To find the momentum using the mass 73 kilograms and the velocity of 7.042 meters per second using this given formula, the momentum of the diver is 51 kilogram meters per second. To find the angular momentum by using the moment of inertia of 820 kilogram meter square and the angular velocity of 2.10 radians per second using this given formula, the angular momentum of the diver is 1722 kilogram meter square per second.
Ways to improve on how you dive are by placing your most dominant foot over the rim of the pool. Next, you should point your arms above your head, but your elbows must be kept straight and your upper arm should be tucked against your ears while your chin is tucked into your chest. Then you should push off and dive into the pool. By doing this, your body should be kept straight, and as you dive, your legs should be together and pointed. Finally, once you push off and dive into the pool, enter the water at an angle to give you a smooth entry, because laying too flat will result into you having a painful belly flop.